Good morning everybody and greetings of the day. I am Professor Rohit Rastogi from ABES Engineering College, Ghaziabad, and here I am going to present some facts and figures through charts, graphs as well as facts and proofs about the different software industries, that what is current marketing trend in the software industry and how the software engineering evolved. So this is the topic on which I usually ask my students that this is a subject which you will apply even after passing out from your graduation, even after 10 years. The rest subjects you can forget, but this is the subject you will take hands-on experiences as well as you will apply the theories and the principles, methodologies and techniques that you are studying here, that you will apply there in industry as a practical. In the evolution of the software, I want to say that presently the software industry is in crisis. There are majority of the cases that the softwares are getting failure. They are having a very less success ratio and very high failure rate. So this pie chart you can see that the success ratio shown by green portion is very less, about 16% only, and the failure ratio about 31% is having a sufficient weightage, and most of the failures of the softwares are due to the wrong estimation, lack of proper estimation about the cost, about the schedule, about the manpower, about the infrastructure and human resources. So we can directly or indirectly feel the importance or need of the software engineering, that proper planning, proper estimation and the systematic study and the approach of the software engineering is very important trend in the current software industry. This is a very sorry figure, as I told earlier, that most of the softwares are cancelled, they are having restarts, they are having the problems of the over-budgeting, over-cost estimation and over-scheduling. The successful softwares are around 28%, and this data is done by compiled by different software agencies, survey agencies, and out of 28,000 projects this survey was done, and these data and this IBM is a big giant industry in the software production, and its analysis says that 31% of the projects are cancelled and 53% are over budgeted. Out of 100 projects, even 94 projects are restart. Restart? What do you understand by restart? After 1 month or 2 months of software production, we see that software is not going to be developed in proper direction. And we say our team that please, we have missed this fact, we have missed this important feature, perhaps our requirement specification was wrong, perhaps our design or analysis phase was wrong, and then we have to forcefully restart the software, and again leads to the over budgeting as well as over cost estimation. So this graph I want to explain about the relative linkage of the cost of hardware and software with respect to time. If we have a journey from 1960s till today, we can see that the y-axis is showing the ratio of the hardware cost as well as of software cost, and numerator was very high, means hardware cost was very high, and at that day, through the history of the hardware production, we can understand that the hardware was so large, so bulky, as about the size of a room, so that the people have to stand on those machines and then to operate it. We can remember the theory of Pascal machine, Charles Babbage machine, one woman computing machine, and other punch cards and those machines which were used at that time for the software production. At those times, Ada, Pascal, Fortran and other languages were used to design the softwares, and we can see that the software cost was also high. The numerator as well as denominator were sufficiently large, and so the graph point is at top of the chart. And gradually the time passed out, and in last 30-40 years we saw a great change in the hardware cost. It is a great thanks to the hardware production managers as well as industry that they were successful to bring the hardware cost gradually and continuously down. And we can see that numerator was down, numerator was low, and so the graph comes exponentially low. Here I will also like to mention the significant Moore's law, which was produced by Dr. Gordon Moore, who was president of Fairchild Semiconductor Corporation, and it was a big giant in the chip designing industry at that time. And the amazing and astonishing fact about this law is that this law proved true for around 35 to 40 years. In the industry of software and hardware, which are considered as the most challenging, unpredictable and continuously changing industries, where after even 1 week or 15 days the technology very fast change, a law is successful and true for 35 years. Definitely it was the miracle and power of the fact that Dr. Moore put in the law. And in this graph we can see the x-axis shows the time and y-axis shows the productivity of the hardware and software. Dr. Moore told that in every 2 years, means 24 months, the chip size will be reduced to half, and the number of transistors, diodes and semiconductors in the chip will be doubled. After few years, Moore made a correction in the law and changed the fact of 2 years into 1.5 years, means around 18 months. So the new law was that after 18 months, the size of the chip will be reduced to half, and the speed, memory and capacity as well as number of transistors and diodes used in the chip will be doubled. And here it is the miracle of the nanotechnology, that the power of the technology we can feel that in our wristwatch, in our calculators, in our other smart electronic gadgets. We can see that the chip size is going to be reduced and decreased day by day, and their capacity and functionality, computation power increases very rapidly. Again, usually I talk to my students and I feel sorry when they answer me about the definition of the software. As per them, software is only the group of some coding or length of line of codes or some programs, but it is not correct. Actually, the software is collection of some programs, documentation as well as operating procedures. Means, besides writing a program, it is also an important responsibility of the developer and the programmer to provide documentation as well as operating procedures to the client. So, in a nutshell, we can say that software is nothing but the collection of programs, documentation as well as operating procedures. If we talk about the program, it is the coding in different languages like C, C++, Java, .NET or other programming languages. In documentation, before understanding it, we should understand about the software development life cycle, which is acronymically said as SDLC. SDLC is nothing but the whole life cycle of a software in which a software takes birth and then it is dead. And the whole journey from taking birth as an idea to the retirement of the software is compiled as the software development life cycle. So it includes from generation of an idea in the brain of a particular person, the need. We usually understand that necessity is the mother of invention. So some brilliant idea comes in a particular vein, and as a seed, it grows as a tree. So seed is an idea and tree is a developed software. So that idea is procured, then it is a problem statement is prepared, then planning is done, different estimations are done, and proper scheduling, cost estimations, budgetary estimations, infrastructure, resources estimations, human resources, manpower resources and technical resources are taken care of, and after that the requirement analysis and specification are done. Then design comes in the picture, implementation, coding and testing is done, and maintenance is a continuous phase and it goes on. Basically, it is said in the software industry that the 80% revenue is generated by the software maintenance. So this is the loophole, this is the key feature that the software developers, the big giants in the industry, keeps in their hands. They charge from the client as per the MOU signed between together, and they design the software, and after that if client demands any changes, any rectification, they charge for that under the maintenance section. And after that, after a particular lifetime, particular time period, when the software gets competition through market pressure, peer software, competition and the need of change, then software is retired if it is unable to sustain with the changes. So this is basically the whole life cycle of a software, and in which the important portion is requirement analysis and specification. So we are talking about that software is the collection of programs, documents and operating procedures. So in document, in the requirement analysis phase, the developers are required to generate the formal specification techniques as well as different UML diagrams, unified modeling language diagrams. UML diagrams are of mainly two types: structural diagram and behavioral diagrams. In structural diagram, the major diagrams are ER diagram, data flow diagrams, state chart diagram and activity diagrams. In the behavioral diagrams, class diagram, collaboration diagram, deployment diagram, sequence diagrams, which talks about the behavior of the softwares in different phases and different time zones is taken care of. So requirement analysis, specification and design are majorly represented by different diagrams, so that other persons, other developers, project managers, clients, they can also understand about the software in the absence or without the help of the developer. The implementation is represented by source code listing and cross-reference listing. Usually, it happens that system analyst is the person who helps the developers to analyze the software as well as to design the critical section of the software. There may be possible some hectic codes, complex features or some very scientific calculations that are difficult to code. Then ready-made applets or ready-made design codes may be used by the developers, which are called which may be understood as cross-reference listing. But the major portion of the software is designed by the developer self, and it is called as source code listing. After that, testing of the software is documented with the help of test data, test views, and test results. Software is tested out of 5 inputs whether it is working correctly or not, then 50 inputs, 500 inputs, and 5000 inputs. Means we have to check whether the software is functioning correctly as per the requirement of the client or not is called as validation, and at the developer end, when the software is tested and it is working correctly as per the given input or not is called as verification. Also, it is the responsibility of the software developer that they have to prepare a program, they have to prepare documents, as well as they have to prepare the different operating procedures. In operating procedures, they have to prepare the different manuals. It may be user manuals, it may be operational manuals. In user manuals, they have to prepare beginner's guide, tutorials, reference guides, and glossaries, how to install the software and how to administer the software. Through this graph, I want to explain about the different phases of the software production with respect to time. Here you can see that in the y-axis we are explaining about the productivity, and in the starting of the graph, in the initial stage, there are different phases like procurement, planning, and requirement specification, and at this time the productivity rate is about constant. After certain time, we can see that the graph goes drastically down, exponentially down. It shows that the improvement is required and a good level of design as well as proper understanding of the coding at the technical level is required. And here the learning begins. It is the intuition and experience of the project manager that the right person is placed at the right position. The right time decisions, proper infrastructure, and human manpower sources implemented in the software production leads to the software success. And as we move on, the software graph, the production graph shows that it is in the least level, and it is the patience of the software developer and the project manager that they should not pitch here. And here the role of testing and maintenance comes. Testing is actually working as a kind of filter. Like in filter, we extract different errors and ill materials out of the membrane. Similarly, in testing, different bugs, failures, errors, and faults are identified and they are rectified by different techniques. And as we discussed earlier, that maintenance is an ongoing phase and continuously working through the life of the software. And after certain time, the software leads to the retirement phase. So, in this section we can see that the productivity is gradually increasing and up to the certain level it is in constant situation. That in the useful life phase, like when we apply the coding and testing portion of the software development, the failure intensity is at the lowest level. And if testing is not done properly and debugging is not done properly, the test data, test views are wrong, and we are not able to identify the errors, faults, and failures, then again the failure intensity increases and the maintenance cost increases, and after some time if software is not applied with the different configuration management, change management, and re-engineering and reverse engineering processes, then wear out phase of the software begins, and after some time software come to the dead state. Through this graph, I want to explain the need and importance of the change factor and how different versions of the softwares are developed. X-axis is dealing with the time and failure, Y-axis is dealing with the failure rate. It is usually said that software is not manufactured like other products. It is basically designed. And the good software is that which is having the feature of reusability of the components. Because till this discussion we can understand that due to the wrong planning it may be possible that we have to come to the previous phases and we have to restart some particular portion of the software again. So if we not apply the change management, configuration management principles, then the blue line in the graph shows that the failure rate is very high, and with the passage of time, after testing and maintenance, it is drastically reduced. But in the maintenance phase, after requirement specification, design and analysis, we have to apply different change management principles. We have to take some technical expertise, feedback from the customers, and the peer competitive software features. We have to take care of them, and we have to change in our code accordingly. But it may be possible that if we change in our code, it produces some side effects, and those side effects are again increasing the failure rate directly. And after that, again we apply the testing and maintenance portion. We find the bugs and remove those side effects by regression testing. Again, failure rate reduced very drastically, and again due to the side effects it goes on, and different versions of the software are prepared by this. After approval of the change component authority (CCA), up to the certain level of expectation and satisfaction, a threshold level is set, and if the developer is able to achieve that level of satisfaction and expectation, that version is accepted, and that is called an actual version. Now we are dealing with the different types of the software. Like you can see here that variety of softwares are spread around the globe and around us. We can't understand the existence of life today without the softwares. We are dealing with the variety of softwares like engineering and scientific softwares for computation purpose, different calculating machines, and business software, financial softwares like banking softwares as well as Tally, etc. System software and personal computer softwares like PDF to Word Converter and Adobe, media players, and MS Office, MATLAB, etc. In real-time softwares, we use the artificial intelligence softwares, weather forecasting softwares, disaster management softwares, and satellite communication and other softwares. In embedded software, we can take example of chip design softwares and those softwares which are designed for a specific purpose, and their code is embedded in a chip, and that chip is used in the gadget, and through the hardware software interface, that particular gadget is dedicatedly applicable for that particular purpose. Web-based software dealing with the variety of web languages, PHP, Tomcat, Apache Server, and others to design static or dynamic websites. So, software's role are changing nowadays, and as per the role and need, that specific software discipline is established. Now I am talking about the different software myths, and there are a variety of perspectives as a developer perspective, market perspective, management perspective, as well as user perspective. In the management perspective, it is usually thought that management is confident enough about the standard and clear procedures of the company. But dealing with the different software developers as per their expertise and their efficiency is a difficult task. Here, the project manager intuition and experience comes in picture. That how in the critical situations, in the difficult positions, and in the difficult codes, and and with the different kinds of clients how to deal with. It is also a good myth in the industry that companies have good computers and good software and it will ensure a quality of product. But this is not true. Only applying the ISO standards or FEI premium label standards is not a guarantee of a good software. Let me say that an error-free or perfect software is a myth, because it will going to the starvation to the computer industry. Computer industries are only earning by the maintenance portion of the software. So only keeping good quality of computers and good quality of software licenses keeping is not the insurance of good software production. Here the technical as well as human resources also comes in picture. In addition to this, the different software specialists and higher skills, longer experience also help for the software production. A big myth in the software industry is that software is easy to change. But let me tell you dear that in the software production, if you are applying waterfall model, which is a sequential and cascaded model, and if you have reached to the NS step, it is very hard to go back to the N-1 step. Until unless you are applying a modular design and reusable component features, function-oriented approach, it is very hard to change in the software. Computer provides greater reliability than the devices they replace, but we all are victims that sometimes the technology cheats us when we need it more. Also, in the terms of customer perspectives, the myths are software with more features are better, but they are very less used and only very few features are really used by the customers. But we have to pay for all the features to the software. Really, we should take care as a customer about the different characteristics and attributes of the software like portability, reliability, availability, security, reusability, usability, maintainability, and as a developer we take care of them, but as a customer the portability and reusability are the important features. Software can work right the first time, but it is not true. A proper training and hands-on experience for the customer also help them to appreciate. In terms of developer, as I told earlier, different attributes of features like maintainability and flexibility are playing a great role for the efficient software production. The only deliverable for the software development is tested code, and that has been cleared earlier that only tested code is not sufficient. Besides that, the developer has to also provide operating procedures as well as documentation manuals to the client. Only to develop a working program is not sufficient. The developer should have also responsibility to develop an efficient code which is not only testably true, it should be having different characteristics efficiently like reusability as well as maintainability. There are four major factors in the software development. Indirectly, we can say these are four components like people, product, process and project. To prepare a ready-made usable object or entity is called a product. And the way of developing that component is called a process, and the whole product is composed of different projects. It may be possible that a product consists of use of different projects, and definitely there is a team of people, technical persons who are working behind it as a developer, as a manager or as. By this presentation I want to explain that software industry is increasing day by day and there is always scope of improvement. There is need to develop efficient techniques, methodologies and The major problems of software failures are lack of estimation and planning, and with the help of proper application of software engineering, we can ensure a quality software production. And with this word, thanks to all of you for listening this. Keep enjoying and stay in touch. In next video, we will discuss about some other important features of software engineering. I am Rohit Rastogi from ABES Engineering College, Ghaziabad. Have a great day. Thank you.